All right, people, let's get into this. All right, people. All right, we are talking about logs today. You learned this briefly, probably in Algebra 2. You also saw a video for it last class. All right, people, here's a couple things that you need to go through and fill in. First off, in this blank at the top, I needed to put a 10 here. Okay. All right, let's talk about what a log really is. Now, on the left and right of your paper, you have the two forms that we've dealt with when it comes to exponentials and with logs. You've probably seen logs at some point with Mr. Isaacson or whoever taught Algebra 2 last year. But this form here on the right, this is a way for you to go through and solve for any particular power that you got on the left. On the left is how you're used to seeing it in exponential form. So let's give you a brief one that we can go through and mess with. Let's say we got 2 to the fourth power equals 16. In log form, what we do is we write this as the log of, first we take the base of our exponent, which is 2. Actually, let me spell log in a less annoying way. All right, log of 2. And then whatever our answer is for this exponential form, we put that as the larger number next to our log. And then it equals the actual power that we have. So our power for this is 4. So what we have here are two different ways for us to write the same problem. Now, when I give you something in logarithmic form, that's usually a way for you to go through and figure out this either by turning it into exponential form and solving for what that power could be, or we can use logs to find out what that power is by solving it algebraically. The more we deal with it, the crazier it's going to look at first, okay? So let's go through and experiment with a couple things. Now, if you don't see any small number next to your log, that means that your base happens to be 10, okay? So that's just one of the few constants it gets with this stuff. So we're going to go through and take a couple of these logs, turn them into exponentials, or some of these exponentials and turn them into logs. Okay. Let's look at our first one that we got here. First one we got is the log of 1000 equals x. All right, first things first, I'm the realist, but I got to stop making that joke. All right, now this 1000, this is what we get after we take some number to the x power gives us 1000. Now, since they don't give us a small number here for our base is automatically going to be 10. And this right here is the logarithmic form turned to the exponential form. Now, right now, we want to just focus on being able to go back and forth between these. We're also going to go through and get a little bit of practice solving them. Okay. All right, over here next to it, we got the log of 5 with 625 equals x. Our x here, that's our power. Our base is our small number, 5. And this equals 625. So 5 to some power gives you 625. Okay. Now for our last one in the top row, we got the log of base 7 and 49 gives us x. So our base here is 7. Our exponent is x. And it is 49. Now for this top row here, if they had you going through and looking at each of these, and your next question would be, okay, well, I was able to go through and convert these both between these different forms. What's my x though? Your question, in order for you to answer it, you'd have to tell me your base to what power gives you your answer. So let's go from the easiest. 7 to what power is 49? Okay. So for this, we know that x here would have to be 2, because 7 squared would give you 49. And that's just solving it. Now, alternatively, let's look at the one in the middle. We got 5 to what power gives us 625? Let's check. You said to the fourth? The fourth would be 25 times 25. Yep, that'd be it. So solving for our x here means that we'd have 5 to the fourth power give you 625. So if you had to go through and solve for your log, and you have to find out any of your missing powers or your missing bases or your actual answer, you would just go through, turn it into exponential form, and start working with that. Okay. All right. And for the last one, we got 10 to what power gives us 1,000. You know that 10 squared gives you 100. So the next best thing after 100, I believe, would be 10 to the third power, which would give you 1,000. So sometimes they'll give it to you in log form, like how they do in the top row here. What if they give it to you in exponential form? Exponential form going into log form, you just have to know what things will go where. So whatever your base is, that's always going to be your small number next to log. Your answer is always the big number next to the log. And whatever your power is what it equals. So let's look at what we got here. All right, starting from the left to the right. If I was to turn this exponential equation into a log form, you would write log first. Our base is 10. So you can either write the 10 or you don't have to write it. That would just be implied. And then in our larger number, we got 0.001, and it all equals our x. So log of 10 with the 001 equals x. Now, if you had to go through and actually solve this, you can go through and figure out 10 to what power gives you this 0.001. This actually would be, I believe, 10 to the negative third. I'll go and write that to the side. All right. Now for the next one, we got another one that's similar to ones that we've done in the past. We got 5 to the x equals 100. Your answer, that comes up next to your log. Your base, that becomes your smaller number. Your power is what everything equals. So everything's going to equal your power. For us, it's x. Over here, we got log of base 5 of 100. And that all equals x. Now this one right here, this is let's see, 25. This is going to give you a decimal for this, okay? So we'll not worry about actually going through and calculating it. I only give you the first couple because we wanted to see the cleaner looking ones. This one gets a little more goopy, okay? Now, last one, we got 35 to the x gives you 8. Again, another one that's less clean, but we're not worried about solving it. So you know what I mean? We're just worried about getting it into a log form. So we got log. We put our base as our small number. So our small number is 35. We take the number that it all equaled, 8. That becomes our larger number. And our power is what everything's equal to. So log of base 35 of 8 equals x. Quite a bit of stuff. Now, next thing that we got to go through, let's look at some of these other log forms and try to go through and switch them up. Okay. I want you to go through and do these on your own. I will let you know right now the small number for our last one is 10. Even though they don't write it, it's implied to be 10. So go through, write that up real quick. Convert them either to exponential if they're not in exponential or into log if they're not in log. All right. We got 3 problems. Could I get 3 volunteers to tell me what's going to go on? What's happening with all of these? Can one of y'all give me an answer? You said 6 to the what? Okay. Remember, the way it works, 6 and x, those two come together. That big number over here on the left with the log, that's what it all equals. Nice and easy. All right, what about the one in the middle? What's it going to be? We know it's an exponential. We need the log form. What's our log going to be? Okay. So we got a log 0.4. What other number is going to be over here? Okay. And we got x. Perfect. All right. Now, if you got any algebra popping off, like how you do for the last one, treat anything that's in a parenthesis as that's one number. Even though you don't know the whole thing, you know that's together. Okay. So, what would be our new problem? All right. 10 to the y. There's only thing one left. So, that's going to be x plus 2. So, all in all, when we're dealing with logs, it's just important for you to really know how to structurally go from one thing to the next. If you're able to go from one thing to the next, that's like half the battle, honestly. If you're just trying to go through and do it just one way, though, it's gonna be a little rougher. I'm not gonna lie. It does require you to go through, be very deliberate, very exact as you're going through this. Okay. All right. Any issues on this? Any questions? All right. Let's check. We're gonna put this into our notebook. Grab your notebook. Let's see where we're gonna be at right now. It's been a minute since we've gone through and get some glue to you. So let's see what we got to do. Why am I rhyming? I don't know what's happening, folks. I'm sorry. All right. Let's pull this up. All right. Last time on Dragon Ball Z, we were on page 74. We need to get this on to 75 because we gotta break at least 100 in these books, folks. Okay. So 74. Hopefully you had 7.2. But this new note that we had is going in on page 75. Okay. If you don't got any glue sticks at your table, we got some glue sticks underneath the blue fan over there. If you need liquid glue or staples or tape, tape is over there. Staplers should be inside of the box. And if you need liquid glue, let me know so I can get it to you.